Okay, TRIZ place great importance on the concept of identity. Okay, idea system. Okay, whenever a technique system is improved, the goal, the target is to make it close to the ideal state. What is ideal state? That means low cost, fewer resource, and minimal waste. We can the product can consuming. Okay, so we just take give you an example to explain. Okay. Actually, we have a meal processing factory in South Africa. They shipped, frozen meat from the South Africa to the United States by, by air, by using airplane. So it had to keep the meat frozen. We have to use the refrigerator equipment, okay, during flighting, okay. So we seeking to reduce the cost, transportation or refrigeration equipment cost and the increased competitiveness. Okay, so the factory owner explored way to lower transportation expense, such as increase the amounts of the meal shipped each time. So from the tree's perspective, okay, so we can have the alternative solution. We let the airplane fly at the altitude about 50,000 to 25,000 feet, where the temperature is about 22 F 2 degrees C. Okay, so under such temperature, the frozen can keep the meat can be frozen. We don't need any refrigeration equipment. So this example, told us how utilize available cost-free, resource can make the technique systems move close to the identity. Okay. So next we introduce the contradiction matrix. Okay, so contradiction matrix is the most common used tools in TRIZ. Okay, so Azula, point out when the technique systems face to, opposing requirements, such the situation called contradiction. Okay, he actually he clarifies the contradiction into two types. Okay, physical contradiction and the technique contradiction. Okay, what is physical contradiction? Okay, physical contradiction arises from a single element of a system. Okay, it must satisfy on two opposite requirements in the same time. Okay, for example, a rule, can a tool to measure something. Okay, a rule should be long, as long they can measure large object. Okay, but they have to sure enough to easy to carry out. So that's physical contradiction. Okay, you know, the parameter is the same one. The size should be long, and the size should be short in the same time. So that's physical contradiction. Okay. So one single element, in this case, that's mean size. Okay. Next we talk about technique contribution. Okay, what is technique contribution? Technique contradictions happens when you have to improve one parameter, but it will cause another parameter getting worse. In improved one parameter, but the other one parameter can be get worse. So this contradiction conflicts, that means technique contradiction. Okay, therefore, compared to physical contradiction, technique contradiction, they concern to the relationship between two factors. Okay, so physical contradiction, they only concern one single parameter. Okay, so that's the difference between the technical contradiction and the physical contradiction. Next, we use this slide to tell you when we use different methods to solve technique or physical contradiction. Okay, so first we have a problem. So we have to identify, any they have any technical contradiction. If yes, we use the contradiction matrix. Okay, if no, we have to check if they have the physical contradiction. If yes, we use the principle of separation. Okay. Next, we talk about the method to solving physical contradiction. Okay, actually we use the principle of separation to solve the physical contradiction. Okay, so actually we have 4 separation principle. Okay, the first one, separation in time, separation in space, phase transmission, and the last one is move to super system or the subsystem. Okay, so we give you an example. Maybe you can easy to understand. The roof of a building. Okay, is majorly used for protecting from rain. Okay, from rain, especially the typhoon in Thailand. Nobody, lots of the house, their roof is disappear. Okay, so when it's not raining, the full roof seems unnecessary. But having more, it can avoid some fresh air into house. Okay, so the roof should be tight enough to prevent rain from the entering, but not so tight that it break airflow and the sunlight. So right now we applied the principle of separation to this physical contradiction. Okay, why we use the why we consider is physical contradiction. That means the parameter is the same. We talk about the sense in the same parameter roof. Okay, roof. Okay. Next, we use the four principle of separation to generate some ideas. First one, separation in time. So we can design a foldable route. Okay, so route. So when it's not raining, we can fold it up. Okay, when the weather getting worse, we can unfold it to provide a shield. Okay. In second one, separator in space, we can use the porous materials for the roof. Okay, the poles block, the rainwaters when they can allow air and the light pass through in the same time. Okay. Okay, actually it's a magic materials. Okay, the third one, we use the principle of the phase transmission, or we can say is sometimes is a structure separation. Okay, we can make the roof from special materials that become solid when it's contact with water and return to the porous and the breathable state when dry. Okay. The last one is we can use the principle move to supersystem and subsystem. Okay, in the part of the supersystem, we remove the roof. Okay, altogether and protect the living space by other tools, such as have a transparent glass cover. Okay, so we did not need a roof, right? In the part of the subsystem, we remove the roof and use a layer of heat flow. Okay, a layer of heat flow to protect, to remove the raindrop instead. Okay. Next, we provide another easy, simple example of using the principle of separation. Okay, so our problem is actually you use the coffee cup as our the target. Okay, coffee cup need to keep the coffee hot, but also also comfortable to hold. However, if the cup keep hit wheels, it's become too hard to touch. Okay, so it's a physical contradiction because we talk about the sensing coffee cup. Okay, so we use the four separation principle. Okay, so usually in space, we make the coffee double walled. The inner wall keep coffee hot, and the outer wall stay cool to touch. Okay, and the separation in time, we allowed the cup to heat it only while drinking. Okay, only while drinking. Okay, just you have a self-heating cup that turn on when lit. Okay, the phase in the principle of the phase transmission, we use the heat-sensitive materials that become an insoluble when hot, and keeping the outside surface cool. Okay, that's cool. Different materials. Okay, and the last time we use the super system. Okay, so we instead of changing the cup, we use a cup slab. Cover. Use the slab to protect hand from the heat. So in the reload, from this principle, we can solve, the physical contradiction.